Hi, let me tell you about another great Manning book, the AI Pocketbook, written by Emmanuel Majori.
Language models are computer programs designed to represent human language structure. Advanced versions, known as large language models, LLMs, like OpenAI's GPT-4o, Meta's Llama 3, and Mistral AI's Mixtral 8x7b, perform complex sentence analyses and generate new text. LLMs are sophisticated autocomplete programs that predict the next word in a sentence. They are created using machine learning, analyzing vast amounts of data, and are self-contained and static, requiring periodic updates. LLMs generate entire sentences by using their output as new input. For example, given the prompt "the Eiffel," the LLM might generate "tower," then use "the Eiffel Tower" to develop the next word, and so on. Special code words like "end of text" signal the end of the text generation process. RAG enhances LLM capabilities by retrieving relevant documents from a database and inserting their content into the prompt. This allows the LLM to access proprietary or up-to-date information without altering the model itself. LLMs use tokens, which are common pieces of text, to read and generate words. Tokens can be entire words, pieces of words, or special symbols. The vocabulary of an LLM typically contains around 100,000 tokens. The input prompt is subdivided into tokens, and then used to predict the next token. Embeddings are numerical vectors representing the meaning of tokens, with each position indicating how much a token matches a certain topic. LLMs use these embeddings to represent and contextualize input tokens. Machine learning automatically creates embeddings by analyzing large amounts of data, which are then used to predict the next token. Embeddings can be visualized as coordinates in a high-dimensional space, where similar tokens are placed close together, facilitating comparison and information extraction. The transformer architecture, introduced by Google researchers, is the foundation of current LLMs. It processes tokens in 3 steps: mapping tokens to embeddings, contextualizing embeddings using previous tokens, and predicting the next token. The architecture uses a multi-layer and multi-headed attention mechanism to improve embeddings and make accurate predictions. Machine learning designs models with learnable parameters, adjusting them through training to minimize loss and improve accuracy. Stochastic gradient descent, SGD, is commonly used for this. Generative AI models like LLMs produce new content such as text and images. Though technically discriminative, LLMs are often called generative due to their ability to create content. Convolutional neural networks, CNNs, are popular for image categorization. They apply filters to images to detect patterns and downsample the images to make them more abstract. CNNs are also used to process audio and video. Multimodal AI models combine LLMs and CNNs to process and generate combinations of text, images, and audio. For example, a text-to-image model might use a CNN to generate an image from a textual description. The no free lunch theorem states that there is no universally best architecture for all problems. Each problem requires a dedicated architecture tailored to its specific needs. Current AI progress is driven by designing specialized solutions for each task.
Get this book at Manning.com